Hi everyone. Thank you so much for joining us today. This is our first session on web development. So really excited to see so many people joining, and we're looking forward to this session to see what we can learn from Doug. So this is an intro to images and video on the web with a special guest, our Google developer expert, Doug Sillars. First of all, I would just like to quickly introduce the DSC team at Queen's. I'm Michael Downey. I'm a final year student studying business information technology. I worked on placement as a software developer, and I'm really excited for the year ahead for what the DSC is going to bring to Queen's.
I'm Peter Davison. I'm a second year software engineering and I'm part of the core team as well.
Hi there, my name's Jack. I'm a third year computer science student. I'm on placement myself and I've just been in the core team for just over a week now. So, yep.
Thank you very much, guys. So now I'm just going to hand it over to Doug. So I'll stop sharing my screen and hand it over to Doug.
All right, hey everybody, I'm Doug. Let's get the camera right. That's pretty close. Nice to meet all of you. Glad you all came out tonight. I'm going to talk about images and I'm going to talk about video, and they happen to be on two different decks. So bear with me when I switch in between them at the end here. Happy to be here. I'm currently in the east of England, in Suffolk. But I do love Belfast. We've been to Belfast a number of times. This image is actually in West Cork, way out there. It's an ancient castle. The Atlantic Ocean is right behind me in this photo. But one of the fun things about talking about images is I can show photos from our travels. And I'm originally from America, but my family and I have been traveling around Europe for 5 years. So those are some of the images. So what about me? I am doing developer relations at API.video. So my job is to help people understand how to put video on the web, right? So that's going to be the second part of my talk. But I also have been doing stuff on the web for a really long time. I've been helping people make their web pages faster, making their native app. So on how to speed up your Android app. It's a few years old now, like it's a little dated. But if you want to download it, that's the URL. So you can just pop that into your browser and download it. So that's cool. If you have questions, I'm going to take questions at the end. But feel free to reach out. I'm on Twitter. That's my email address, and that's my webpage. All right. So we're going to start off by, this is a picture of an Alp in Switzerland. And this is actually a walkway that's nailed to the side of an Alp, and you walk across it, and it's a mesh bottom. So you look down and you're looking hundreds of meters straight down. And you might wonder, like, other than it being a really cool picture, what does it have to do with an images talk? Well, Ericsson did a study a few years back, and they put sensors on people's heads. And they said, they measured stress responses. And they found out that when people thought about standing on the edge of a cliff, their heart rate went up, they got a little stressed out. But what they stress people out a lot more than standing on the edge of a cliff, right? So when you build a web page and it's slow, or if you build a mobile app and it's slow, that stresses out your customers or your users. Now, if you think about it, a stressed out user is someone who's less likely to buy something, right? So that's a bad thing. There's a lot of research on the performance of web pages. A 3-second delay on mobile causes half your customers to go away. A half-second delay increases frustration, lowers engagement. 20 years ago, both Amazon and Walmart found that 100 milliseconds causes a measurable drop in revenue. And one of my favorite studies of all time is 4% of mobile users admit to throwing their phones when there's a slow mobile website. So, what can we do to speed up the web? And if you think about what web pages are made of, we've got JavaScript, we've got HTML, we've got CSS, but images, huge This is a graph of 10,000 web pages, and you can see, most of them are over 50% in terms of kilobytes of images. So if we can make the images smaller, your web page is going to load faster. So I'm going to talk about some optimizations that we can do to make sure that the images that you put on your website are small, because if they're small, the web page is going to load faster. I don't know if anyone has ever used Lighthouse before. It's a free tool. It's created by Google. It's built into the Chrome developer tools. You can also test it on, I think, PageSpeed Insights. There are a bunch of different ways you can test Lighthouse. You can also test it in a tool called WebPage Test, which is a great performance tool. It's webpagetest.org. And so if you're interested in seeing how fast your web page works, webpagetest.org is a great web page to look at how fast your page is. And it's completely free, and it's open source, and it's just amazing. One thing I do miss about doing in-person meetups is sharing a drink with everybody. So, cheers. So inside Lighthouse, there's 4 optimizations for images. And so I'm going to walk through those and see how the web is using these 4 optimizations today and how it can make your web page faster. All of these tests are done with WebPage Test, which I mentioned earlier. And then there's this other tool that runs WebPage Test on 5 million web pages every month and then throws it all in a database. So all these results are in a database that you can query and see how the web is built. And so I can actually see these 4 optimizations times 5 million web pages and see how people are doing these optimizations on the web. And image quality, and you may have seen this, like if you're ever in Photoshop or any sort of image processing tool, when you save a JPEG, there's like usually a slider that lowers the quality. And of course, as you lower the quality, the image doesn't look as good. But for most images, you can lower that quality pretty far and no one can tell the difference. And so Google actually recommends, Lighthouse actually recommends saving all your images at 85% quality. And the reason they do this is at 85%, just about no one can tell the difference. And it's about half the size of the original image. So there are a bunch of tools that can save an image at quality 85. You can do this inside Photoshop, inside just about any image processing tool. And so I have this image that's 3.6 megabytes. I save it at 85%, and it's half the size, and you cannot tell the difference. So like, it makes sense, right? If you can't tell the difference and you can make it half the size, it's going to download twice as fast. What we find, and this is 2019, 2020 data is about the same, is that half of the web is passing, and about 30% is failing this best practice. And when you fail this best practice, that means you could save several seconds and probably hundreds of kilobytes to make your web page faster. Now, 85% is just sort of a number that works for most images. You can actually go smaller. And there's 2 tools that will help you do this. One is called Booterowgly. All of Google's compression tools are being built by a team in Zurich. And so they're all named after pastries. And Booterowgly and then also structural similarity can actually lower the image quality to where the human eye can't tell a difference. And so I'm going to use structural similarity in the next image. You can't tell the difference, but it's 400K smaller. A little bit more to where the human eye can just perceive the difference. And it went from 1.87 to 1.46 megabytes, so saving 400K, and no one can tell the difference. So that's just going to make the page load faster, right? So we can see, this is the Google recommendation, and this is what we can do with the structural similarity going to that auto setting. We can test these. So with WebPage Test, we can load a web page, and we can see the full-size image on a 3G connection takes 21 seconds. At 85%, it takes 12 seconds. And it takes 9 seconds with structural similarity, right? So we're speeding up the web page just by making the image smaller. The next thing we can look at is the different image formats. As you know, there are a lot of different image formats out there. And one thing you can do for small icons is use an SVG, a scalable vector graphic. The file's a text file. It's basically XML, and you can add it inline to your HTML. It's text, and you can stretch out the image as much as you want. This is the same SVG, and as I stretch it out bigger and bigger and bigger, you can see that there's no jaggies or anything on the edge because it's literally vectors drawing these arcs and circles. So they're a great way to do icons on your web page. And so, for example, I found a web page, a long time ago, and this is still on their web page. I checked again about 2 months ago. But they have this sort of bullseye as a divider between two sections of the web page. And as soon as I saw this in my dev tools, as I was looking at what was loading on the page, I knew something was wrong. I can open it up. And you can see when you don't know what this means, don't worry about it. But basically here we're applying the circle and here are the paths. Like this is drawing this target. Everything afterwards is Adobe Illustrator gunk. And so what Adobe Illustrator does is if you have an original image, it base64 encodes the image and throws it in there as metadata. So this file is on this web page and it's 946 kilobytes. If I click right here and drag to the bottom and then delete it and resave it, 1 kilobyte, right? This mistake here is costing 945 kilobytes every single time somebody visits the web page. They actually have 2 of these images on the web page. They have a red version and an orange version. So it's actually costing like 1.8 megabytes of just garbage that everyone is paying for to download on and making the page file. So you can use gzip to compress a text file and it gets under a kilobyte. Brotli is another compression. It's by Google folks. So Brotli means bread in German. So, right, 500 bytes, right? We can make this 500 bytes or you can make it almost a megabyte and it looks exactly the same. In Lighthouse, they recommend that you use modern image formats. And the image format they recommend you use is WebP. And there's been and they recommended WebP because it's been in Chrome and it's been in Android for a really, really long time. It only got into Edge and into Firefox, I want to say like last summer. And the glaring omission in all of this was anything Apple, right? It wasn't on Safari. It wasn't on iOS. Use WebP. WebP is a format is like 10 years old, but JPEG is like 28 years old. And so in the 18 years in between, they learned a lot about compression. WebPs will save you like 10, 20% over a JPEG, which is why you should use a WebP. Now this summer, something really exciting happened and you can see like it's green except for Internet Explorer. So if you're not supporting Internet Explorer, there's no reason not to use WebP. Right? If you use WebP, your images are going to be smaller. So when I make this image a WebP, after it's been optimized, I cut off, it was 1.4 megabytes, and now it's 1 megabyte, right? Another 400K has been shaved off. If you do have to support IE, you can use the picture tag. And what the picture tag does is it lists all the different image formats that you have. And the browser picks the first one it knows what to do with. So if it knows how to do a WebP, it'll do that. Have an alt text, and the alt text is what's read by a screen reader if somebody can't see images. We can see that we went from 9.5 seconds to 7 seconds on loading that image. If we look, not a lot of usage on WebP. Like WebP has not picked up yet. I'm thinking that now it's supported in Safari, this will pick up a whole lot, and a lot more people start using WebP. The one thing that people do understand is image sizing, right? Because I'm on a laptop, I've got a giant monitor in front of me, I have my phone, right? You serve a different size image to different size screens. And that sort of makes a lot of sense. People understand that. And as an example, here's an image that I took. It's 13 megapixels, 1.6 megabytes. I do all the optimizations we just talked about. It goes half the size to 800K. 13 million pixels, and if I'm on a small little crappy phone, only 500,000 show up on the screen. So you download 13 million pixels, and then you have to throw away 12.5 million pixels. And so that's just, it's wasteful, and it takes a lot of time. And it's sort of like when you buy something from Amazon, and it comes in this giant box, and you have to pull out all the paper until you find out like what's in the bottom of the box, right? We don't need to do that. Like, I know Amazon is trying not to do that, but they still do. We can do better. We're developers. We know how to fix this. And so what we do is resize the image. The other thing that happens is this was a 16 million pixel image down to 1 million pixels. And to decode it on mobile phones, this is on desktop, to decode the image, to throw away 15 million pixels took 78 milliseconds. But on a Motorola G4, it took 200 milliseconds. On this 800 milliseconds, slowing down your page even further because the processor has to like throw away all these pixels. And of course, the processor's firing up and running at 100%. So that's draining the battery faster. The battery's heating up, so the phone gets all hot in your customer's hands. Like, it's really bad. So what we should do is generate a bunch of images, right? Images for mobile phones, for desktop, for tablets, for big screens, and then serve the right one to our users. And so here, when I serve the right size image to my phone, it's only 121K instead of a megabyte. And so, of course, it drops from 7 seconds down to 2 seconds, right? 5 seconds faster, right? 120K for a big image on a mobile app like that, or a mobile website, that's pretty reasonable, but a megabyte is just too large. Then inside the picture tag, you can set different widths. So, you know, at this width, serve this image. At this width, down, serve the right size image for the size of the screen. In this case, I have like 25 of them, which is probably too many, but it's just kind of the point to show that you can do it. Now, the web is doing this pretty well. Like 60% of the web is doing this. Earlier this year, it was 2/3 of the web is doing this, right? So serving different size images for mobile versus desktop, which is great. There's still room for improvement, but we're in the right direction. The last optimization inside Lighthouse is lazy loading. And so the idea behind lazy loading is if you've got all these images on your web page, only load the ones that people can see. And don't worry about the other images. The other images you can load using JavaScript. So you can use the intersection observer. There's a blog post here that talks about this. So you can use JavaScript to load it. Oh, they're getting close to these 3, load it. But if you only have to load 2 images instead of 6 images, the initial load time of this page is going to be faster because you obviously removed a lot of images that have to be loaded. This has had a huge jump over the last year. It was 56% last year. Oh, it's 59%. I thought this was really a big jump. All right. But like 60% of the web is doing this. There's still room for improvement. 30% is still failing. So there's still a lot of room for improvement here. So those are the ones that are inside Lighthouse. There are a couple other things I want to talk about images before I jump on and start talking about video. And it's actually a pretty cool segue because animated GIFs are kind of right on that, you know, right on the precipice. Are they an image or are they a video? And so this is a video I took of my goats back in Seattle when I used to live in Seattle. 4 megabytes, and I turn it into a GIF because we definitely need more GIFs of goats on the internet. But when I turn it into a GIF, it grows by 270%. It gets a lot larger. And if you actually go back to 1990 and you look at the spec for GIF, the only reference it has to animated GIFs in the spec is that GIF is not intended as a platform for animation, even though there is an animated way to use GIFs. Like the spec says you can do it, but like you probably shouldn't. And, you know, if the spec says you shouldn't do it, then maybe we shouldn't be doing it. That's not to say that GIFs are bad. Like, I love the idea of GIFs as the technology, but GIF as a format is bad. So we shouldn't use the GIF format for looping videos. The reason it's for a second, it's literally 15 GIFs every single second. There's no compression through time, whereas video does compression through time. So if I actually make this into an MP4, and then I make it 256 colors, because GIFs are only 256 colors, and then I remove the audio track, right? Because it's just silent. It's going to be playing silently as a movie. I make it 250K. It's 93% smaller. Like, that's incredible. It's so much faster. You might be wondering, but like Twitter uses GIFs, right? It actually says GIF down there in the bottom. But if you open up the dev tools when you're looking at Twitter, you can actually see that they're movies. Like Twitter, Slack, Facebook, anyone that uses GIFs are actually serving movies that loop. And we'll talk about that in the second half. But movies have much, much, much better compression than the GIF. If the idea of like looping goofy videos, like this dog is just adorable, right? Let's make it animate. Come on, animate. Here we go. Like, this is just adorable. Like, we want to have more things like this on the web. Like, this is amazing. But you shouldn't do it as a GIF. You should always do it as a movie. All right, so now I'm going to my slides on video. Present, and let's see if this does it backwards. The other one did it backwards. All right. So, like, images are huge, right? Images are on every single web page out there. Video, I think, is growing like crazy. I think more and more people are going to be putting video on the web. I mean, it's just like 1,000 words, and somebody said that a video is worth 4 million words or something like that. It's just so much more engaging, and people are really interested in video. And I really think this is going to be the future of the web. But there's, just like you can mess up images, like images are really easy to mess up. When you screw up a video, it's really, really bad, because videos are just exponentially larger than images. All right, so we're going to talk a little bit about, we're not going to talk about live video. If you have questions about live video, we can talk about it afterwards. I just don't have any slides on it, just for time. I want to obviously have time for questions at the end. And if I could talk about video for like 8 hours. So like I had to limit it somehow. We're going to talk about video on demand. We're going to talk about short play videos. So like the sort of as well. Streaming or short play videos are like background videos, or like the hero video at the top of the page, or maybe like a short informational video. All right, so like I said, videos are really large, and we want to be really careful when we're dealing with videos because they are really, really big. So in April 2020, this is the 5 million sites in the HTTP archive, right? How big they are in terms of size. The median page at 50th percentile is like 2 megabytes. What about sites with video? Well, as soon as you have sites with video, the median web page is like 5 megabytes. You know, a lot larger, right? As soon as you start adding video, these pages are just much, much larger. And, you know, that's obviously going to impact how fast your page loads. Not so much how fast your page loads, but how fast the video can play. But the median site is 250% larger than the site without video. So, you know, the median web page is 27% video or something like that. All right. Browsers are really smart. When they see a video, they always download the video last. So this is a screenshot from Web Page Test. This is the HTML, you know, the CSS, the JavaScript. These are the images. The video is way down here. It always is downloaded at the end because videos are big and we don't want the video to get in the way of the CSS, the JavaScript, and the images, right? So it's always a lesson to download. But we should talk about the user experience of having that download at the end as well. So when you add a video to a web page, you have a video tag, you add the source, and you link to your video. You can set your video to autoplay, and this won't work, especially on mobile. It might work on desktop, and it only works if people have been to your web page before and pressed play on other videos. you know, Doug has been to this webpage before and watched a video before, so I'm going to autoplay the videos on this webpage. Really, really hard to test, because if you're building a webpage and you press play once, now the browser remembers that localhost always wants the videos to autoplay. How do you test it so it doesn't remember that? Like, it gets really, really difficult to make sure that when you're testing a webpage, you see what a new customer is seeing. Now, if you add the muted tag, autoplay and muted, this will autoplay on all browsers. And Chrome and Safari forced all videos to start in a muted format. This is great. So like when you're in class and you're like, right, you don't want it blasting out. When you're in a meeting, right? I think Chrome and Safari engineers sit in on meetings too, right? We want it to be muted so we don't get busted. You could add controls. So if you add controls, that adds the if you don't add the controls, there's just a video play. So this is sort of like that animated GIF, right? It's going to autoplay and muted, but you can't stop it. With the controls, now you can start and stop the video. You can set a width, you can set a height, so you can control where it sits on the page. You can add a poster. So if the video doesn't autoplay, it'll either pick like the first frame of the video to fill that screen. So if it might be a black screen, you can actually specify a JPEG that'll show up there. You can set it to loop. So autoplay, loop, and muted, this is your animated GIF, right? So if you wanted to put a video in instead of the GIF, you set your source, autoplay, muted, and loop, and it'll just loop through the video over and over again. There's an attribute called the preload attribute. You can set preload equals none. And if you set that, you've got a video tag. The page is 200 bytes. If I set preload equals to metadata, that says download the first couple seconds to get the metadata of the video. Now the video is downloaded 620K. This is default. So if you don't set a preload attribute, it's always set to metadata. Preload equals auto tells the browser download the whole video. Like, I don't care if they're going to watch it or not, just download the whole thing so it's in memory. 31 megabytes. Use this with caution. Like, if you only think like 10% of your viewers are going to watch the video, there's no point in like sending 31 megabytes of video to all of your customers, right? If they're on mobile, that costs them against their data plan. You're paying for it out of your server costs, right? Your website has to pay for, you know, all the traffic in and out, and that's going to cost you money. Metadata is a pretty safe place to be, which is why it's default. Okay, so you can also set multiple sources. And a second source. And this is sort of like the picture tag. The browser will pick the first format it knows what to do with. So if it knows how to play a WebM, it will do that one. If it doesn't, it'll just go to the next one and play the MP4. And all browsers support video except for like Opera Mini, which is like 0.5% of all, you know, users on the web. When we were talking about images a little earlier, I mentioned media queries where you can say, you know, if it's a big screen, serve the big movie. If it's a small screen, serve the small movie. That doesn't work on videos. You can't do this. So don't try it, because this will just always serve the big movie to every single device. The solution is streaming video, and we'll get to that towards the end of the presentation. But I want to give you a couple examples of websites that have completely screwed up the way they're delivering video. And I am an American. This is not a political statement. It really screwed up the way it's delivering its video. And this is the code. And so what is happening here is that we've got a div to hold the video. We've got the desktop video, which is muted, autoplay, and loop. And this is the video. And then we have the mobile video, muted, autoplay, and loop. So what happens when you do this is you download both videos, the desktop version and the mobile version, on desktop and mobile. So if you're on mobile, you've got 20 megabytes of video and you really only needed 6.6. Like, this is just stupid, right? You should only download one of them. If it's mobile, serve the mobile one. If it's desktop, serve the desktop version. It's just sort of common sense. The second example here is, again, a video that loops, muted, and autoplay, right? This is an autoplaying sort of animated GIF idea. But they add a poster. starts downloading the poster. The browser downloads the poster, but as soon as the video is ready to play, it starts playing. So you actually never even see the poster. And that poster on this case was 250K. So it's just 250K of delaying the video from showing up. Because if this hadn't been downloading, we would have a lot more video downloaded. The video would have started playing sooner. So if your video is going to autoplay, you don't need a poster. This is a demo that I'm going to show you here. And so we'll go to Climb, Iowa. And this isn't just Climb, Iowa. It is thousands and thousands of web pages. All right, so if I load it on the desktop, you can see we've got this cool animated background video of people at the climbing gym. If I load it on mobile, you don't see the video, right? The video in the incognito tab with Chrome DevTools open, so you can see this. If you haven't used Chrome DevTools, it's a great resource here. So Chrome DevTools will tell you all about you can see all of the elements on the page. I'll show that in a second. I'm gonna go to the network. I'll make it small again. And then what I want to do is I want to watch for media downloads. And so I'm going to load Climb, Iowa. And what we can see here is we've got this image right here. But if we look, we've downloaded 4 megabytes of a video, right? So what they're doing, and I can show you here in the, let's see here, where is it? Source, no, elements. I've got to go bigger. All right, if we look here, hero, maybe it's hero top, I'm not sure. Oh, video, here's the video. All right, so here's the video. When I make the screen smaller, we can look at the CSS, and they have the CSS is set as display none. And so what the browser is doing is the browser reads, hey, I need to download this video. And then it lays out the page, and it's like, oh, but I don't need to show the video. Right? So display none does not mean download none. It downloads the video and then decides not to display it. And so every single mobile user who goes to this web page is downloading 4.5 megabytes of video that they can never, ever, ever see because it's hidden from them. Kind of wasteful. It's not just this web page. I would say this exists on, of all videos that, web pages that have a background video, I'd say it's on like 80 to 90% of them. So it's something that's, you can just use some JavaScript, right? If the screen is this small, no video at all. If the screen is this big, video. All right, back to sharing, not sharing, presenting. I always click the wrong button. Done. Present. All right, so display none. Again, it's still going to download, so you should not download it if you're not going to show it on the screen. All right, fourth example. We've got a preload equals, so this one has controls. It says preload equals auto. And so what that's saying is download the whole video no matter what. And then if you look at the file name, this is a 90 meg. Download the whole file. On Chrome, mobile Chrome, it gives up after 61 megabytes. But still, if you're on a mobile connection and you download 61 megabytes, like that's going into your data plan, right? This could actually cause issues that the developers are not intending to cause. All right, last example here is another demo. So this web page, is a modeling agency. And we'll open up the DevTools. And we'll play it. All right, so what you can see is we've got a background video and they're, you know, models doing modeling things, right? What's Go. Whoops. You probably can't tell, but if you see this, right, there's audio. So this video could actually be like 5 to 10% smaller if they had stripped out the audio. And because it's a background video, no one can hear the audio anyway. So you might as well strip it out. So if you have a background video, you should always remove the audio. All right, I'm going to press the right button this time. So like these are just some really simple ways to make your video smaller. You can use JavaScript to serve the correct video. So don't serve 2 videos like the Trump Tower website does. If you're autoplaying the video, don't have a placeholder image. Don't use display none. Don't download the video at all if you're not going to show it. Resize the. What are the dimensions? How big is it? Like, do you really need an 88 megabyte image video on your web page? If it's silent, don't use any audio. And then the next example is on the next slide. I didn't order my slides correctly, but we're going to order our formats correctly. So I showed you this before, right? If you have a video, you can have the first source and you can have the second source. MP4 is supported in every single browser out there, whereas WebM is supported in, I think, everything but Safari. And WebM gives you better compression. The videos are generally smaller. However, the way this works is the browser says, can I play an MP4? And it says yes. So if they actually looked in their logs, 100% of their views are going to be the MP4, and 0 people are looking at the WebM because of the way they ordered them in the video tag. To make things even worse, in this case, they're serving a 73 megabyte video to everybody. And if they merely switched these 2 files to like 75% of the web, they'd be serving half as much content, right? Just like that. The other thing that they're doing is they're serving this all out of Amazon S3. And like, if you use Amazon for your web page, that's awesome. Like, I think S3 is a great service. However, at 73 megabytes, it costs about half a penny every single time this thing downloads. Amazon charges you 9 cents a gigabyte. And, it actually becomes measurable for this video. So, be careful about that because it can actually add cost to your web page. So like you've got this 1080p video, it's 5 megabits per second. You're on a really fast connection, like no problem. It's going to play just fine. However, if you're going to play, right? You're trying to stuff a really fat thing down a really small pipe, and that video isn't going to play. So we need to make the video smaller. Otherwise, you're going to just get the spinner, and nobody likes a spinner. If you get the spinner on the web, people just drop. So we want to size the video for your end users. And like I said, the video tag doesn't have media queries. You can't resize it. But video streaming does do this. And so I'm going to talk a little bit about video streaming because this is really the way to show longer videos on the web in a way that makes it look really good on a mobile phone versus a desktop versus a tablet versus a big screen. So the way video streaming works is you have a video and it breaks the video into little segments or chunks, usually like 2 seconds to 5 seconds long. And so it downloads the first 2 seconds and then, 0 to 2, 2 to 4, 4. And so how does it know which segments to download? There's a manifest file. It's like a menu that describes all of the segments. And it actually looks like that. It says, each segment is going to be about 10 seconds long. The first segment is 5 seconds. This is the byte range. This is the URL. The second segment is 3 seconds. This is the byte range. Here's the URL, right? It just walks you through what needs to be downloaded. What makes streaming even cooler, and this is the variable bit rate, is that you can build different versions, right? So you can have a 360p for really small screens. You can have a 720p for intermediate screens. You can have a 1080p. You can have a 4K if you want. And so what ends up happening is you have all these different streams and the right size video will play for the right device. The other cool thing is that it can deal with the network of the device. So even if you have a really big screen, if you're on a really it still plays. It may not look super crisp and beautiful, but it's going to play. If the network all of a sudden gets a lot better, it may jump up to a higher bit rate, or it may fall back down to a lower bit rate, right? And this is what's really cool is with a regular video, just an MP4, you're stuck with whatever the connection is. If you start serving that 1080p video, you're stuck with that bit rate, even if they go into an area that doesn't have as good a coverage. So what happens is you end up with a master manifest file that describes the child manifests. And this is what the player uses to figure out what needs to be played at any given moment. And it lets the video stream on any size device, at any different network speed. So it just works. It takes away a lot of that complexity that we were talking about. Like you have to use JavaScript and encode all these different videos. No, you can just stream it and it just works. Do this, right? You can create the manifest files. You can create the segments. There's a tool, it's an open source tool called FFmpeg. You can do this all yourself. It takes some technical some technical study, but it's not terribly hard. So when you have a bunch of different streams, the master manifest file lists the different streams. So this is listing 3 different streams with different bandwidths and different resolutions, right? 720p, 540p, 360p, 1.4 megabits per second, 800 kilobits per second, 500 kilobits per second, right? And the different codecs that are being used. So this is how streaming works. You generally need a JavaScript player to play the video, but it's responsive, it's network aware, it's adaptable, and it can lead to faster video startup because it may start off at a lower quality for a fast startup and then zoom up to the faster quality. If you ever watch a Netflix video at 360p, why? Because these videos download really, really fast. So they can start the video really, really quickly and then jump up to the higher resolution 4 seconds in. So this is my pitch slide. So I work for API.video. I got to put one slide in. So I apologize. If you're trying out video streaming, just try API.video. We've got a free tier. You can upload your video. It creates all the streams. You get a player automatically, and you get analytics. This is kind of complex, right? There's a lot going on here. This is all abstracted. It's an API. It's a RESTful API. You just upload your video, and the video is created for you automatically, and it's really easy. It's a great service. I'm biased, but you should try it out. And with that, I want to thank you all for listening. I know I covered a whole lot in the last 4. If you have any. You can put them in the chat, I guess. I don't know if people are allowed to come off mute.
You can pop
them
in
my
the chat.
voice is, and I'm sorry that my voice was breaking up 33 minutes ago. I just saw that. There's so many things to be looking at when you're doing a talk, like the chat sometimes loses out.
Oh, we have a question.
Okay, so why would you use the so the image tag, let me get back to the other slide deck here. It's up here. There are a couple things that the picture tag lets you do over the image tag. One of them is responsive images. Let me find that. You can use a bunch of different sources inside the picture tag, so you can do different sizes and you can do different formats. So actually, if you wanted to, you could actually have 3 different size WebPs, 3 different size JPEGs, 6 different sources in your picture tag, and the browser would go through all the WebPs and then the JPEGs if it doesn't know what to do with the WebPs. And then it could go through the sizes of the WebPs and pick the exact right size for the device. Say, oh, this screen is this side, insert the code, and it just does the one WebP. Or you could just have a static picture tag that has all of the different images, and you'll guarantee the right size image is downloaded for that device. They're both HTML5 standard, so they'll work in any browser as well. So you don't have to worry about using one over the other. What Chrome extension was I using? Oh, so I'm not actually using a Chrome extension. Chrome DevTools is like the greatest thing in the world. And so what I will do is, we'll just do CNN.com. And so if you want to open up DevTools, and I know the short key, but it is view developer. But if you open up developer tools, you can put it at the bottom. If you're testing a mobile site, you can pop it on the side here, and then you can emulate a mobile site. So I could say I want to emulate a Galaxy S5, right? And so this is the screen size of a Galaxy S5. It actually, if I come over here, I don't have it set up. I just got, you can actually also, so I can rotate the screen. You can also, you can set the CPU speed. So you can say this is a low-end mobile, a mid-tier mobile. So, you know, rather than using your laptop at full throttle CPU, it'll actually emulate the CPU of a mobile device. All right, so let's just do the Motorola. And so there's a bunch of stuff happening here. Let's just see all. So this is all, right? We load up the CNN webpage. We get a 301 to go to www.cnn.com, and we get another 301 to go to this www, and then we go to edition, which is the European version. So HTTP CNN to HTTP www.cnn to HTTPS www.cnn to HTTPS edition.cnn. So if it's the first time you've been to CNN, you end up with 3 redirects before the page actually loads. A 301, and then a 302. We can see the JSON, so we can actually see what's being downloaded here. We can see the response, and we can see, right, all the information that's being downloaded. If you want, and you can sort all that's inside CNN. It's actually, if you look, it is it 9? Let me do this again. So we've got 12 megabytes downloaded, 140K is CSS, 9.8 megabytes is JavaScript. So it's 12.3 megabytes, but 9.8 megabytes of this web page is JavaScript. There's just a lot of JavaScript. Other things we can see here. You can see the size of downloaded. So like this JavaScript right here is downloaded 18 megabytes, but when it's unzipped, it's 50 or 18 kilobytes unzipped, 53 kilobytes. So you can see that that there is zipping all of the text files going over the network. If these two numbers are the same, that's showing that your server doesn't have gzip turned on to zip these files. Look at the CSS. What's the biggest one? We've got 20K here, and it's this one, right? So the main image on the CNN webpage for mobile is 22 kilobytes. What is this? Is some video? Maybe? Yep, so there's some videos being downloaded. They only download the first little bit of them, so it's, you know, a couple 100K, 255K. You can see fonts, like you can see, this is just what's being downloaded. Then we could actually see the HTML. And as you mouse over, you can see the different parts as it highlights the different parts that you're looking at. Right, so this is the main part. Like this is sort of the header. You can see it's highlighting up there. Like you could do like, I know their book. You can look for memory leaks. You can check the performance. You can do, that's not Lighthouse. Lighthouse is in here though. Where is Lighthouse? More tools. There's a lot, right? There's just so much stuff you can do inside DevTools to really figure out how your web page is going. Quick demo on Lighthouse. So let me find Lighthouse in here. Here's Lighthouse. So part of it is that they have so many menus that it rolls off. All right, so to do a Lighthouse test here, I can say generate a report. Now it's auditing CNN.com, and it's going to give me some scores. You get a score out of 100, and you want to be as close to a 100 as possible. So we'll see what Lighthouse is. So it's loading the page, and then there's a giant JSON file of data that is then going to parse and to hopefully display the results. It loads it a couple times to see if stuff is cached or if it reloads when it's been cached. And we can see that CNN is getting a 5 out of 100 for performance, right? That's bad, right? It's getting good SEO. It's getting okay on the best practices. The accessibility is actually really good. But like what it's saying is there's a lot of JavaScript on that. Remember we saw there was 9.8 megabytes of JavaScript. It's saying that if you remove some of that JavaScript, it could be 11 seconds faster on a 3G connection. If you preloaded keywords, important, so download those first. You could make the page 11 seconds faster. It looks like the JavaScript is sitting on the main thread a lot, so it's actually preventing the page from rendering. We got some third-party tools that are slowing it down by 2 seconds, right? So these are all best practices, and you can actually like read more about it, and they actually have documentation. So if you click this link, like there's a whole blog post of how to do this. The great thing about it, it is really, really well documented. So you can see that like, for some reason, there's 12 seconds of script evaluation on the main thread on this phone. And so you could make that run a lot faster. Web page test will give you some similar results, webpagetest.org. Just to be fair, let's test it in Europe. And we can test it in Ireland. And this will be a desktop. It's an emulated desktop because it's just an emulated device in EC2, which is Amazon Cloud. But you can see they have devices all around the world. We have North America, we have South America, Europe. So if you're building a web page and you're like, I wonder if my web page is slow when I load it in India, you can actually test it with this tool. How fast does my page load in Sydney? You can actually test it. Which is actually kind of interesting. So we can say, we can change the network speed, let's say a 5 megabit connection, and we hit go, and it'll give us our results in just a couple seconds. All right, so it's actually already testing, and we'll have some results in just a few seconds. So if you want to start web development and go into the field, where should you start? Self-directed. So we can see we've got some bad grades here. They didn't compress images well. This is the desktop version now. You can see it's loading a slightly different version of the page. But there's a lot of information here. There's a guy named Matt Hobbs who his Medium article on how to use web page test is now it started off as a 3-minute read, but now it's like a 67-minute read. There are books on how to use web page test. So there are a lot of tools out there. A lot of people have written documentation on how to do this stuff. But if you want to just get started on building web pages, I'd recommend just playing with it. Build your own web page, open it up in DevTools, because DevTools will tell you when you're making a mistake. Read some of the documentation on MDN has great documentation, or Angular or something like that. They all have great documentation. And there are a lot of really good classes like Udemy and even Khan Academy has great classes on how to get started with building on the web. You know, when I create a demo, I still just create HTML and JavaScript, and I just write it in a text file. Basically, that's the blog post. But like I'm building a Node app right now, and like it's just HTML with JavaScript, and I'm just writing it in a. You know, I've been building web pages that way for a very, very, very long time. And for a simple demo, that works. If you want to build something fancy, you're probably going to end up using a framework like React or Angular or Vue or something like that. And so it probably makes sense just to do a primer and to learn about all those different things. And this web page that I'm building here is written in Node.js. So there's HTML on the front end, and then there's a back end doing computations. It's actually live. So the idea of this web page is did I kill my server? I didn't. All right. So the idea is if you build a web page that has videos on it, if you're letting any old person upload videos, you want to make sure that they're not uploading stuff that's inappropriate for your web page, right? So if somebody uploads this video, I'm actually sending it to a service that looks at 1 frame per second to make sure that that it's safe for work, right? So you can actually look here. These are the videos that this thing decided it decided the James Bond trailer was safe. There's a video on Nazis that it decided was safe for work. Right. All of these videos it decided were safe for work. It decided that so I found a YouTube video called Cigarettes and Movies. But it actually shows up like, so I'm actually filtering, show me all the videos that have smoking in them. Show me all the videos that do not have smoking in them, right? And interestingly, I don't know if you guys know the TV show Baywatch. Like, it's a pretty old TV show, but it's just about people running around in swimsuits. And actually, this algorithm decided that Baywatch was not safe for work. And SFW, and yeah, Baywatch. I'm going to put that into a live demo because that's inappropriate. But this is a tool that, you know, it has a front end. So I built all of these pages, and then there's a back end that when I upload a video, it actually does the analysis. Is this video safe for my customers to look at? And I'll also be the first one to admit that I am not a designer, and it does look pretty crappy. But it's a demo, right? It's just supposed to work. So the links work, and the buttons work, and the code works. Yeah, I'm not a designer. But that's a whole nother field as well. If you're interested in that, you know, there are people who make their living designing the web pages and building the style sheets to build web pages. What was used to check the video frame to frame? I'm writing a blog post. Hopefully I'll have it up early next week. But it's called The Hive. It's not free. It's not super expensive, but they do go frame by frame, and I'll actually open up the blog post. So every single frame, they give you a JSON, right? So it's not safe for work, which means that it is safe for work. Logic, right? So this one is safe for work, and is looking for all sorts of things, right? Like, are people in their underwear? Is there nudity? In this case, this was from Baywatch, right? So there's a woman in a swimsuit. There is a shirtless guy. What else? They're not holding guns. They're not holding knives. I don't know the difference between a little bloody and other blood or very bloody, but they're trying to measure like how gory it is, I guess. If they're smoking or not smoking, if they're Nazis or no Nazis. And I tried to do the Indiana Jones movie because it has only half a second long, so it doesn't actually find the scene with Nazis in it. And it looks like, is somebody flipping the bird, right? It looks for all these different things to see how appropriate the video is. So in this case, there's no Ku Klux Klan, there's no flipping the bird, and there's no terrorism. I asked them what they're looking for terrorism, and they're only looking for the ISIS flag. So the only thing they consider a terrorist in this library is if it's ISIS. That's a whole nother thing, like machine learning, like what was it taught to identify as a terrorist? In this case, it's just one flag, so it's not necessarily the best tool, I would say. But it actually works really, really well. Like, it was able to tell me when the act in their swimsuits, not nudity, swimsuits. And so these always add up to 1, right? So 0.99999 and 4 times 10 to the minus 5th add up to 1. But it was a fun thing to build, right? Just because it's kind of cool. And if you want to see how it totally works, I will have a blog about it. I'll probably tweet about it next week when I get it finished.
And the link to me, I can share the link with the
I'll do that for sure.
Any more questions from anyone? No. We're all good then. Awesome. Are you able to share the slides back over?
I can share the slides. I will send you I'll send you the links after the presentation.
Okay. So thank you very much, Doug.
Of course.
It's been great. It was very interesting. I'm sure everyone here loved the presentation. Thank you very much.
Yeah. And if you guys have any questions, you think of something later, feel free to send me an email. Let's find, I'm sure I put that here in my slides somewhere. It'll be in my slides. Send me an email or hit me up on Twitter, and I will be sure to answer you.
Thank you very much.
Cool.
So I just want to gather some feedback from everyone. So are you able to stop sharing your screen, Doug? And then
I can indeed. Stop sharing.
Get some feedback. Thank you very much. So Peter, do you want to take this one?
Cool. Yeah. Thank you very much, Doug. I enjoyed that. If anyone wants to join the mailing list, I'll pull that link up in the chat now. You just get a notification every time we want to do any of the sessions as well. If you want to join that, you'll just get told, and then you can sign up straight away. if you guys can give us feedback, you don't have to do it now, maybe afterwards, but if you can fill out this form, thank you very much. That'll be really good to give us some feedback. Give Doug some feedback as well if he wants it. There's a QR code on the screen and there's a link in chat if you would like to fill it out. That'll be perfect.
Thanks, Doug, for that. That was very interesting. Just on a few events coming up, just on following on from today, we've got a web development event next week. We're just going to be building sort of a basic application using HTML, CSS, and JavaScript. Going to code along, so we'll send a few prerequisites out that you can get yourself set up for. That'll be on our social media, so just look out for that. And then we've got a few things in November and December on Flutter and Firebase, which are both Google developer technologies. So look out for that on our social media. Cheers.
All right, so I'd just like to give a final thank you to everyone, Doug for the great presentation, and the guys in the core team for helping make this happen. So thank you everyone for turning up, and we'll see you next week at our next session. Thank you. Bye-bye.